Welcome to a new video for the Pure Mathematics course. Now we will start a new section in Chapter 2, which is the lines, and we will represent the relationships by the lines. The first term in this subsection is the slope of the line. How to get the slope of the line? The slope of the line is for two different points, x1, xy, and at other order pair, x2, xy2, is the vertical changes over the horizontal changes. I mean that equal to y2 minus y1 over x2 minus x1. Mention four different slopes where zero slope or undefined slope or positive slope or negative slope. Here, the first case, the horizontal slope where the slope equal to 0. This means that the line or the function is parallel to x-axis, and whatever the value of x, it always equal to the same value for y. So the slope in this case equal to 0. Another case, which is the undefined slope. The undefined slope means that the line of the function is vertical line. Number 3 is the positive slope, where the line rises from right to left, where the slope of the line is greater than 0. And finally, the negative slope, where the line falls from left to the right, where the value of m is less than 0 and means that the negative slope. Here are the four cases for the slope in our function or the line segment. Now, let's move to another very important definition, which is the point-slope form. The point-slope form of an equation of the line through x1, y1 with slope m equal to y minus y2, y1 equal to m multiplied by x minus x1. This means that the same rule for the previous slope form or rule, that we only get the y1 y minus y1 in the left hand side and other values in the right hand side. I mean that we will take only one point where y1 and x1 and the other 2 points y and x remain unknowns. So we can do it in this form, which is y equal to mx plus p. We can get m by using the previous rule for the changes in y over the changes in x, and we can get by using the point slope form by using this rule. Another form for the linear equation, which is the general linear form, where we can get all the values in the left hand side and the right hand side equal to 0. Here the coefficient of x multiplied by x and coefficient of y plus the constant it should equal to 0, and what is known by the linear general linear form. Another expression, which is the vertical line, where x all the time equal to the value of a, and the horizontal line, where y all the time equal to the value of y-intercept, which is p. Now let's move to the example number 37, where determining a line from 2 points. Find an equation of the line passing through -3 and 8, and the other order pair is 4 and -2. We first should get the value of the slope, which is m. Note that we haven't the line function or the equation, just we have 2 points and we want to get the equation or the linear form. So we should first get the value of the slope, which is the changes in y over changes in x. Here, let's say that the first order pair x1, y1, and the second order pair is x2, y2. Then when substituting by these 2 points in our rule, will be x2 minus 8 and -3, which and 4 minus -3. Take care that there are a negative sign for the rule and the negative sign for the points. So the m in this point will be negative 10 over 7. Now we will use the point slope form to get the value of p, and by getting y unknown and x unknown and getting the value of the slope which we have in the first step and substituting by any of the 2 points. We have already 2 points. Choose any one of them and substitute in the point slope form. So the value will be 7y minus 56 equal to negative 10x minus 30. This is by multiplying the both sides by 7. Then we will make all the steps like the steps of any equation to get y alone in the left hand side and the other values for the slope and y-intercept in the right hand side. Note that the slope is equal to negative 10 over 7 and the value of p, which is the y-intercept, equal to 26 over 7. Remember that the value of p or y-intercept is the value when x equal the value of y when x equal to 0. Now let's move to another example for converting forms of equations of lines. Here, find the general linear form of the line whose slope-intercept form is y equal to negative 2 over 3 x plus 4. By clearing the fractions, we have that multiplying 3 to the both sides, we get 2x plus 3y minus 12 equal to 0. So this is the general linear form for this line. Another one where 3x plus 4y negative 2 equal to 0. And the requirement is find the slope of the slope-intercept form for the general linear form. So we should get y in the left hand side and all other values in the other side. So 4y will equal to negative 3 times x plus 2, and dividing both sides by 4 we get y equal to negative 3 over 4 plus half. This means that the slope m will equal to negative 3 over 4 and p equal to half. Another example. Find the slope and the y-intercept of the line with the equation y equal to 5 times 3 minus 2x. We will use the deductive property to get y equal to 15 minus 10x, and this means that the coefficient of x equal to negative 10, where this is the slope of the line, and y-intercept, the value of y when x equal to 0 equal to 15. Let's move now to the last part in our chapter, which is the parallel and perpendicular lines. We have two lines, y1 and y2. Maybe the two lines are parallel to each other, where the two lines have the same slope and never intersect, or the two lines may be perpendicular to each other. This means the interaction of the two lines give a right angle with 90 degrees, or the two lines neither know the intersected by not parallel or perpendicular. Let's move how to know the slope or the each case without drawing the two lines. If the two lines have the same slope, where m1 equal to m2, this means that the two lines are parallel to each other. If the two lines slope m1 equal to negative 1 over m2, mean the negative sign and 1 over the second slope, this means that the two lines are perpendicular to each other. If the two values not equal or not equal to negative 1 over the other one, so the two lines neither parallel nor perpendicular. Let's move to the example to see how to get the or determine whether the two lines are parallel, perpendicular, or neither parallel nor perpendicular. For the first one, y equal to negative 5x plus 7, and y here equal to negative 5x plus negative 5x minus 3. Now, let's note that we compare the two slope for the two lines. For the first line, m is equal to negative 5, and the second line, m is equal to negative 5. So, m1 equal to m2 equal to negative 5. So, the two lines are parallel to each other. For the second example, where y equal to 5x plus 2, and the other line is negative 5x plus y negative 3 equal to 0. Please note that if we compare two lines, they should be in the same form, which is the slope form, or which is y equal to mx plus p. So before determine whether they are parallel or perpendicular or neither, you should get the two lines in the same form, then compare them. Now we will first convert this to the form for y equal to 5x plus 3. So we have the coefficient of x equal to 5 and the other is equal to all 5, so the two lines also are parallel to each other. Now let's move to number 3. We have 4x minus 8 equal to 12 minus 4x. Now the 4 coefficients of x in the first, where the slope equal to 4, and the second one, the slope equal to negative 4, where they are not equal and not equal to the 1 over m2, so the two lines neither parallel nor perpendicular. And fourth one, also we should convert the equation first to the form for y-intercept. So 3y equal to negative x negative 5. Divided both sides by 3, so we'll get y equal to negative 1 over 3x minus 5 over 3, where here the coefficient of the first line, which is negative 1 over 3, and the coefficients for the second one is negative 3. I mean that m1 equal to negative 1 over 3 and the m2 equal to negative 3, which means that the two lines neither parallel nor perpendicular. They only may be perpendicular if this equal to 3x and the other equal to negative 1 over 3x. So take care that you should convert first in standard form, then compare and decide whether they parallel or perpendicular. Here we finished chapter 2. I'm here and use the examples and exercise in your reference to revise again, and we are ready for any questions. Thank you.